Hello and welcome back. This is problem number 26 in my set of videos, one for each problem in this AP Physics C multiple choice test. So this is the third question in this set relating to this scenario. I'm going to read the scenario of the set and then go into the problem. So two satellites of masses m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speeds v1 and v2. Their orbital radii are r1 and r2. Assume the mass of the planet is much greater than mass 2, which is greater than mass 1. This question is asking us if U1 is the potential energy of this planet satellite system containing the satellite of mass m1, and U2 is the potential energy of the planet satellite system containing the satellite of mass m2, which of the following expressions best represents the ratio of U1 divided by U2? Alright, so this problem again is about potential energy. The equation that we're going to use for potential energy in this case is U, potential energy, is equal to the negative integral of force. And force in this case is the gravitational force. So we can write that in. U is equal to the negative integral of G M, this is M planet, over R squared. Alright, so once we integrate this, we're going to come up with U is equal to, so the negative sign isn't going to matter here because it's just asking for a ratio, so we're not going to worry about the negative sign in this case. So this is going to come up with G M M P times, so now we're going to have 1 over R initial minus 1 over R final. And if we look at the radius here, the initial radius and the final radius, all the radiuses are the same. The radius is a constant thing. So instead of this, we're just going to have it be 1 over R1 because that's the radius we're dealing. Or when we go into U1, we're just going to talk about R1. We're just going to like ignore this part of it. So let's set this up for U1. Let's go over here. U1 is equal to G M1 MP times 1 over R1, and U2 is going to be equal, we can just plug in the subscripts here because it's going to be the same variables again, is equal to G M2 MP times 1 over R2. So now we can just divide this because the ratio we're looking for is potential energy 1 over U2. So divide. We can cross out the G's. We can cross out the masses of the planet because these are both constants. And what we're going to end up with is U1 over U2 is equal to, alright, so we're going to have our M1 on the top, M2 on the bottom, and then let's look what happens when we divide these. So 1 over R1 divided by 1 over R2. Instead of dividing, here we can multiply the reciprocal, so it's going to become R2 over R1. We're going to get that little switcheroo, and that switcheroo gives us our answer. So M1 R2 over M2 R1 is going to give us C, and that is our answer. So to solve this problem, we use potential energy U is equal to the integral of force. And then from there, we know that our force is the force of gravity, which is G M over R squared. From there, we plugged in, we made it for, so we plugged this into the equation for potential energy, we integrated, and then we plugged in the variables for the first system, which is U1 for V1 and M1 for the particle orbiting on the inner radius, and then we did the same thing for the particle on the outer radius. From this, we were able to simplify and divide, and then got our answer. Alright, thank you for watching. Let me know if you have any questions as always, and check back in for video number 27.